In this nugget, we get to walk through the solution or solutions for trouble ticket number 8. Let's begin. So why is it that ASW1 cannot ping the IP address of 10.1.1.1, which is the interface serial 2/0.12 interface over on R1? Well, my friend, that's what we're going to solve right now. Let's begin right here on ASW1, and let's go for a ping to 10.1.1.1, which is the IP address owned by R1. And sure enough, we can't get there. However, we do have some U messages, which means unreachable. So some device in the path is talking back to us saying, hey, I can't get there. I can't forward your packet. So let's narrow that fault domain and find out who is saying that by doing a trace route to 10.1.1.1 right here from ASW1. And it appears that it's the device at 10.1.1.9. And if we look at our topology, that would be our good friend R3, who is saying that the 10.1.1 is unreachable. Now, before we go up to R3 and investigate R3, I want to share with you a little bit of magic that's happening right here on ASW1. On ASW1, if we issue the command show IP route, now this is a layer 2 access switch. IP routing is not enabled on this device, and it currently has no default gateway set. So you might ask yourself, well, how in the world did we forward a packet if we don't have a default gateway configured? I mean, just a few moments ago, we were sending packets that were using 192.168.1.130 as our first hop as the packet got forwarded to its destination. And the answer to why this even worked at all without a default gateway is proxy ARP. DSW1 and DSW2 have proxy ARP enabled on their interfaces by default. And because ASW1 does not have a default gateway, it did an ARP trying to reach 10.1.1.1. So .130, which is DSW2, saw that ARP request for 10.1.1.1. And based on DSW2's routing table, it thought it had a route. DSW2 did an ARP reply back to ASW1 saying, yeah, hey, to get to 10.1.1.1, use my layer 2 address. At which point ASW1 started forwarding frames at layer 2 to the MAC address of DSW2. And if we issue the command show ARP, ASW1 thinks that the 10.1.1.1 resolves to this MAC address, and the back half of that is 2B and 4 zeros. And that MAC address, if we looked at DSW2's VLAN 200 interface that has the IP address of .130, it would have that MAC address. In fact, let's go verify that right now. So on DSW2, we'll do a show interface for VLAN 200, and there's that MAC address right there. Now, the question is, if we had a troubleshooting scenario where an access layer switch, for example, couldn't ping a remote destination, do you think the test writers knew that proxy ARP might play a role? And the answer is, I don't know. Because it could be that the writers of the question were expecting you to need to put a default gateway on ASW1 to make it work. So what I like to do in our troubleshooting for this scenario is let's go back to ASW1 and let's go into configuration mode and let's specify an IP default gateway of 10.2.1.254, which is the HSRP address on VLAN 10. And with this command show IP interface brief, I just wanted to verify the IP addresses that I have. So if we choose to use this as a default gateway, because that's an HSRP address which is fault tolerant, and because we do have an IP address in VLAN 10, this would make a good fault-tolerant default gateway. On the flip side, if we're supposed to be using VLAN 200 for the management of our network devices, including ASW1, then it would make more sense to go ahead and use the default gateway of either .129, which is DSW1, or .130 of DSW2. So if we issue the command show IP route, the default gateway that now shows up should be the one that we just configured, which it is. So that looks great. And just for grins, let's verify that we can ping our default gateway at 10.2.1.254, and we can. Hey, and check it out. That was without having to bounce the VLAN 10 interface on DSW1, which is perfectly fine. I'll take what I can get. So now locally, ASW1 doesn't have to rely on some neighboring router running proxy ARP. It's got a default gateway. Let's now check out our path between ASW1 and 10.1.1.1. We'll do that with a trace route once again to 10.1.1.1. And once again, we have R3, who has the IP address of 10.1.1.9, which cannot forward it any further. So let's make a road trip over to R3. And here on R3, let's do a ping of 10.1.1.1. Maybe R3 can reach it. And as we expected, R3 doesn't have the ability to reach 10.1.1.1. So let's peek at our topology for a moment. 10.1.1.1 is right here. That's our objective. We're sitting at R3. So if we have a failure in the OSPF network somewhere on this path or on this path or on R2 in general that's sitting between them, that could prevent us from reaching 10.1.1.1. So let's do some additional show commands right here on R3. First, we'll issue a show IP route. We'll say, please just show us the OSPF routes that you've learned. And you'll notice out of all these OSPF routes that we have, none of them have been learned off of the serial 2/0.23 interface, which is the interface between R3 and R2, which leads me to believe we may not have an IP OSPF neighborship with R2. So next, let's check and see what neighborships we have with OSPF with the show IP OSPF neighbor. And we have a neighborship between us and R4, and there's no neighborship between us, R3, and R2. There's our fault domain. Somewhere between R2 and R3, OSPF isn't working. And since we're right here on R3, let's find out which interfaces on R3 are enabled for OSPF, as well as which areas they belong to. So serial 2/0.23, which is the interface between R3 and R2, is enabled for OSPF. It's part of area 0. And serial 2/0.34 is enabled, and that's the interface between R3 and R4, and we have a neighborship with R4, so we knew that was working before. So let's go peek at R2 and see what R2 has to say about it. So here at router 2, we'll do a show IP OSPF interface brief just to verify which interfaces have OSPF enabled. So at the moment our concern is serial 2/0.23. The configuration on R2 says it's part of area 0 based on this output, but we do not have an OSPF neighborship with R3. We can verify that here with the show IP OSPF neighbor, and sure enough, we've got an adjacency with router 1, but not with router 3. And let's do a sanity check right here to verify that R2 can ping R3's serial interface. So to do that, we'll do a ping to 10.1.1.6, which is R3's serial 2/0.23 address. And sure enough, we got basic connectivity. We just don't have an OSPF neighborship. Next, let's go ahead and get out the microscope and start taking a look at the OSPF as it applies to serial 2/0.23 right here on R2. And to do that, we use the command show IP OSPF interface serial 2/0.23. So a few things we want to look at here is the network type point-to-point, which would be appropriate for a point-to-point sub-interface for frame relay, which is what we're using. The timers have to match, so we have the default hello timers of 10 and 40. That looks okay. Let's issue the same show command over on R3. So here on R3, let me give us some visual separation. Let's do a show IP OSPF interface serial 2/0.23 here on R3. So here on R3, it also is a network type point-to-point. The timers are matching. The IP addresses also look good. We have 10.116/30 on R3, and here on R2 is 10.1.1.5/30. So they're both on the 10.1.14/30 subnet. That looks okay too. So what's different as we go between R2 and R3? So as we go back and forth between R2 and R3, as I'm toggling back and forth, I notice that one of the outputs is just significantly bigger. So R3 has a longer output than R2. And I want to see what the difference is. So the last line here on R2 says suppress hello for 0 neighbors. If we go to R3, the last line says, oh, there it is. It says message digest authentication enabled, youngest key ID is 1. This highlighted portion does not exist in the output of R2. Let's go to R2 just to confirm that. So what that would imply is that we have an authentication mismatch between these two peers, or two would-be peers with OSPF. They're not neighboring up because they can't agree on authentication. So let's take a look at R3's config. So here on R3, we'll do a show run for interface serial 2/0.23. And right here we have the IP OSPF authentication message digest, as well as a message digest key. So we have both of those elements here on R3. Let's go take a peek at R2. So here on R2, we'll do a show run, interface serial 2/0.23. And look at that, we do have a key, it's there. But we are missing this statement right here. The IP OSPF authentication message digest is not present on the interface of R2. So what we could do is go over to R2, and here on R2 we can go into interface configuration mode for serial 2/0.23. And we'll simply add the missing piece. Now, the other option is we could have taken off the authentication off of R3, and that would have worked as well. But it's very likely that if OSPF authentication is present on one side, they want it present on the other side as opposed to removing it from both sides. And our neighborship just came up across that serial link. That's a very good sign. So we'll type in end, and let's go do our test from ASW1. So here on ASW1, let's go ahead and do a trace route to 10.1.1.1, and survey says success. However, now that I look at this, we're not using our default gateway still. And what I would have expected to happen is I would have expected it to use the 10.2.1.254 as its default gateway. But based on results right here, it's not. So even though we have full connectivity to 10.1.1.1, it's going over a path that I wasn't expecting. Let's do a show IP route just to verify our default gateway of 10.2.1.254. Let's do a show ARP. And here is the mystery revealed. So when we're trying to reach 10.1.1.1, because we still have that in our ARP cache with the layer 2 address of .130, we are still using that as our next hop, even though we have a correct default gateway in place. So let's do this just as a sanity check. Let's do a clear ARP cache on ASW1. Let's do a show ARP. Oh, great. And that just refreshed it for us. Because this is on interface VLAN 200, I'm going to go ahead and just shut down interface VLAN 200 for a moment, bring it back up, and that should get rid of the ARP entry. So we'll go into configuration mode for interface VLAN 200. We'll do a shutdown and no shutdown. We'll do a show ARP, and there we go. So now 10.1.1.1 is no longer in our ARP cache. So now if we use the up arrow key a few times and we do a trace route to 10.1.1.1, I'm expecting it to use the correct default gateway. And that would be through the .254, which is being managed in HSRP by DSW1. So when the TTL is exceeded at DSW1, the reply back to ASW1 is coming from the VLAN 10 interface, which is 10.2.1.1, and that indeed is our correct first hop. So the mystery of the wacky ARP cache has now been resolved. So our fault domains in this nugget could have been a couple things. Number one, we had ASW1 that had no default gateway, and as a result, it very likely may not have been able to reach a remote destination if ProxyARP had not been enabled on DSW2. In either case, we fixed that by adding a default gateway to ASW1. So that, in addition to cleaning up the ARP cache on ASW1, we were able to verify it was taking the predictable path. Our second fault domain was on R2, and the technology was OSPF IPv4 routing authentication, and the correction was to include the correct authentication commands on R2's interface, so it could then become an OSPF neighbor with R3. I am glad that you joined me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.